In this video, we're going to be looking at lesson 11.3 on sector area and arc length. This lesson has two parts. For the first part, we'll answer the essential question, how do you calculate the area of a sector? And for our second part, we'll talk about how to find the length of an arc. There are formulas to calculate both of these things. Let's start with a sector of a circle. First, the definition of a sector is a region that's bounded by two radii of the circle and their intercepted arc. So you can see in the picture, the radius is AC and CB. So there's my two radii. And the arc is kind of the curved part of the circle. Well, the sector is the area of that region that's colored orange on the screen, the shaded region. And the area of a sector is related to the area of a circle. You might recall that the area of a full circle is pi r squared. Well, to get the area of a sector of a circle, you take the full circle and you multiply it by the degree measure of the arc divided by 360. So that's your full formula. And then again, it's related to the area of a full circle, which is pi r squared. We're just taking a fraction of the full circle. Arc length is a fraction of the distance around the circle. So it's the distance along an arc measured in linear units. So we're not talking about the degree measure of it, we're talking about its distance. So the first thing we are going to recognize is that it's related to circumference. The circumference is the distance around the full circle, all the way around. Well, the circumference equation is c equals 2 pi r. For an arc, which is a portion of the circumference, we take 2 pi r times the measure of the arc divided by 360. So again, maybe that's 20 degrees, and then we have that. And it's going to give us the distance along the arc, which is this distance along that curved path right there. Also, let's make note that the full circumference, that's the distance around the entire circle, is c equals 2 pi r. We're taking that full circumference and multiplying it by the degree measure of the arc divided by 360. Remember, the full circle is 360 degrees, so we're looking at the part of 360. Let's try some examples now. We're going to start off with the area of a sector. Find the area of the sector in terms of pi, that means leave the pi in your answer, and rounded to the nearest hundredth. For rounded to the nearest hundredth, that's where you're going to use your pi button. All right, the first thing we can do is write down our formula for the area of a sector. And then you can look at the picture and see that the radius is 3 and the measure of the arc is 80 degrees. So let's plug those values in. Pi times 3 squared multiplied by 80 over 360. And then before we go to our calculator, let's simplify 3 squared to 9. So this is 9 pi times 80 over 360. And I'm going to show you a little trick on how you can enter this on your calculator so that it gives you the reduced fraction as your answer. So on your calculator, if you type 9 times 80 over 360, there's a fraction button on the calculator. I'll show you it in a minute. It's the N over D button. And then when we hit enter, this one actually divides evenly. But if it didn't, we would be able to have the reduced simplified fraction. So I have 2 here, and then it would be 2 pi. So just don't lose your pi. The area of our sector is 2 pi, and since it's an area, it would be square inches. For the approximate value, that's where you can, again, grab your calculator, approximate value 2 pi. You might need to put a decimal point there to force your calculator to give you the decimal. And when you do that, we'll have 6 pi is equal to 6.283, and then it keeps going. Now, when we round to the nearest hundredth is 2 decimal positions. The 3 in the third decimal position tells us to round down. So the approximate area would be 6.28 square inches. We'll look at how to type that in the calculator in the next example. So here's our try now, and we want to find the area of the sector. The first thing we can do is copy down our area formula. Area equals pi r squared times m over 360. Notice that in this circle, r is 6, and it's 120 degrees. So pi times 6 squared times 120 over 360. That's 6 squared, order of operations. We do that first. 6 squared is 36. You got the pi in there. Multiply by 120 over 360. Let me show you how you can type that in your calculator. On your scientific calculator, or this also works with a graphing calculator, you can type 36 times, and then I'm going to use the fraction button to get that 120 over 360. So 120 fraction button, that's the n over d key right here, and then put 360 in the denominator. Then we'll arrow out, and that'll give us 12. So the exact answer is 12 pi. Don't forget to put the pi back in. To get the decimal value, its approximate value, you might notice on your calculator that if you try to do 12 pi, it'll just give you 12 pi again. So to force the calculator to give you the decimal answer, you can do 12 decimal point and then your pi button, and now it will give you the decimal value of 37.699. So now for our exact area of the sector, we have 12 pi, and that was square centimeters. The approximate answer, we need to round to the nearest hundredth. So that 37.699, this would round up. So after 0.69 comes 0.70. So approximately 37.70 square centimeters. The next example here is going to be finding the length of an arc. And the formula for finding the length of the arc is L equals 2 pi r times m over 360. So it's similar to the area of a sector, but it starts off with 2 pi r, the circumference equation, instead of pi r squared, the area equation. Okay, now if we look at our picture, we can see the radius is 6 meters, and the arc measure is 40 degrees. Let's put those values into our calculator, or into our formula, 2 pi times 6, and then it's 40 over 360. And as we did in the previous example, we're going to simplify this here first before we multiply it by the fraction. This is 2 pi times 6, which is 12 pi, and then 12 pi times 40 over 360. We can type that in our calculator using the fraction button, and this one is not going to divide evenly, so we are going to need that reduced fraction that we'll see on our calculator. So here's 12, and in fact, you could even use the pi button right now. So 12 pi times 40 fraction button 360. Now this works on a scientific calculator, but I believe if you have a graphing calculator, it will automatically put the pi value in there and won't give you out the pi. So that's why usually when I do this, I leave the pi out of my calculator and just do 12 times 40 over 360. And then there's our exact value. And now to get the pi, we can do this times pi, which again will give me that. So if I want to get the decimal, I could type 4 pi divide by 3, or you can go second table, and that switches a fraction to a decimal. So there we go, 4.188. You could also, again, just type it in, so 4 pi divide button 3, and by using the divide button, it will give you a decimal value. And now for our final answer, we need to include the appropriate units. The length here is just a distance. It's the distance along this curved path from G to H. So 4 over 3 pi meters. And then for the approximate answer, we're going to round to the nearest hundredth. This 8 rounds up, so I'll say approximately 4.19 meters. Let's try one more example here. So on this one, we're again finding the length of the arc. We can write down our formula here for arc length. This time, the radius is 8, so 2 pi times 8, and then the arc is 134 degrees. I'm going to simplify this 8 times 2 to 16 pi, and then multiply that by 134 over 360. Again, when we type this in our calculator to get the exact value, let's just do 16 times 134, fraction button 360. And the calculator will give you 268 over 45. We just need to remember that we have to put the pi back in there. So the exact arc length is 268 pi over 45. Now you could also, if you want to see this as a decimal, if you use the fraction to decimal button, and when you type this in your calculator, it's 5.95 repeating pi. So I could, if I want to do instead of exact, this is the best. This is exactly 268 pi over 45 centimeters. I could also say about 5.96 pi centimeters. Then to get my decimal approximation, I'm going to type in 268 pi button divide by 45. And the calculator will give us, when we use the pi button, 18.7099. Rounding to the hundredth, we have 18.71. And there's our arc length. Here's one final example for your try now. I'm going to have you try this one on your own. Please pause your video now, and then when you hit play again, the solution will be posted. Please pause. Here's your solution. You can see that I put the 4 in for r. 2 pi times 4 was 8 pi. And then I did 8 times 135 over 360 in my calculator and got 3. So the exact arc length is 3 pi, and then the approximate value using the pi button is about 9.42 centimeters. And this is the end of lesson 11.3. Thanks for watching, and good luck as you practice areas of sectors and lengths of arcs. Bye.